Hi, sixth graders. Today you are going to be doing your notes for 2.2 kinetic and potential energy. You should have already made a copy of the note sheet. It looks like this. Okay, and as we go, you'll be filling in the yellow boxes. There are a couple other things that are yellow that are highlighted on here, but make sure you follow along with each of the letters as we go through the screencast. Our objective is I can calculate kinetic and potential energy and explain how these two types of energy are related. And our essential question is, what are kinetic and potential energy? Now remember from the last section, energy is the ability to do work. And we're going to be learning in this lesson the two main types of energy. Now there are other types of energy that fall under kinetic and potential energy that we'll get into later on. First, we have kinetic energy, and kinetic energy is the energy of motion. So it's the energy that an object has because it's moving. So the skier going down the hill has kinetic energy because the skier is moving. Once the skier stops moving, he or she no longer has kinetic energy. The faster the object is moving, the more kinetic energy it has. And the more massive an object is, the more kinetic energy it has. So if I dropped, let's say, a bowling ball and a ping pong ball, and they both, I dropped them both, the bowling ball would have more kinetic energy than the ping pong ball because it is more massive. How do we find the kinetic energy of an object? Well, the kinetic energy of an object, we take 1/2 mass times the velocity squared. And the units we're using for energy are joules. So here's an example. So a fowl has a mass of 100 kilograms and is moving at 8 meters per second along the beach. What is the kinetic energy of the fowl? So we have the mass of the fowl is 100 kilograms, and the velocity or speed that it's going is 8 meters per second. So to find the kinetic energy, we just plug in the numbers into the equation. We get 1/2 times 100 times 8 squared. Now remember PEMDAS, we always do our squaring first, okay? So I'm going to rewrite it. I have kinetic energy as 1/2 times 100 times 64, because that's 8 squared is 64. Then I'll do 100 times 64 is 6,400. Then multiply that by 1/2, and I would get 3,200 joules. Now remember, with PEMDAS for multiplication, it really doesn't matter what order you multiply it in. You'll get the same answer anyway, but for the squared number, you have to square it first, then you can do the multiplying. So we're going to try one on this next one. I'm going to try to write right on here and see if this works. I've never done it, okay? So a 6,200 kilogram elephant, African elephant, charges at a speed of 10 meters per second. What is the elephant's kinetic energy? Well, I know that in order to find the KE, the kinetic energy, right, I take 1/2 times mass times velocity squared. So my mass is 6,200 kilograms. So I'm going to plug that in. 1/2 times 6,200 kilograms. And my velocity is 10 meters per second. So that's going to be times 10 squared. Now I just have to multiply that out. Remember, I'm always going to start with the exponent. So I'm just going to rewrite this. 6,200, 10 squared is 100. And again, remember, calculators are always fine when we're doing math. I do 6,200 times 100. Let me grab my calculator here. Times 100 times 1/2. And I get 310,000 joules. So that is the kinetic energy of the elephant. Oops. Oh no, all of my writing is still on there. Hold on, let me go back. Let me go back and delete it all. Sorry about that. Slightly irritating to have to delete this all, but that's okay. We'll just do it. Probably could have paused the video. All right, moving on. Next slide. All right, now we're moving on to potential energy. And whereas kinetic energy is the energy that an object has due to its motion, potential energy is also known as stored energy. And it's the energy that an object has due to its position, condition, or chemical composition. So let's watch a little example video here.
Welcome to Moo Math and Science. In this video, I'd like to look at several examples of potential energy. Potential energy is stored energy. When you combine potential energy and kinetic energy, you have mechanical energy. As this roller coaster moves up the hill, energy is used to overcome the force of gravity. You lose energy, but the coaster gains potential energy. At the top of the hill, the coaster has potential energy. As it moves down the hill, it now has kinetic energy. Combine these two, and you have mechanical energy. This water moving over this ledge is another example of the combination of potential and kinetic energy. The white water at the bottom of the ledge is a result of the potential energy of the water at the top of the ledge and the kinetic energy of the water falling. This spring is an example of elastic potential energy. The potential energy is equal to the work it takes to stretch the spring, the distance stretched, and the spring constant K. This piggy bank sitting on top of the box is an example of gravitational potential energy. You can see what happens as it falls. This stored energy is now released. This match demonstrates chemical potential energy. Once the chemical reaction begins, you can see how the energy is released. This battery is also an example of chemical potential energy. These solar panels are storing the energy of the sun and are another example of chemical potential energy. Fireworks have chemical potential energy. When the chemical reaction begins, the stored energy is released. And finally, one more classic example of chemical potential energy whenever you mix Mentos and Diet Coke. So there we go, several examples of potential energy. Thanks for watching, and Moo Math uploads a new math and science video every day.
All right, so that was showing some examples of potential energy. So one example is elastic potential energy, and this is due to something being stretched like a rubber band. So when you stretch a rubber band or pull back a bow, like a bow and arrow, okay, before you release that rubber band or before you release that bow, it has potential energy, okay? And once we release it, that potential energy changes into kinetic energy, and the arrow shoots and it moves. Or if you fling the rubber band will move. So the potential energy changes into kinetic energy. Another type of potential energy is called chemical potential energy, and this is energy stored in chemical bonds, like in food. So we know that we have to eat food in order to get energy. So what we do is our body eats food and it breaks apart these chemical bonds at the molecular level in the food, and our body, it releases energy, and our body can then use that energy for all of its processes and for movement. But it's stored in that food until it's ready to be used. Another type of chemical potential energy is a battery. So when you put a battery into something, let's say a toy, Okay, the bonds in that battery break and allow that toy to work or to have kinetic energy. A third type of chemical potential energy is gasoline in your car. We know that cars don't run without gasoline. And when we put gas in our car, it's stored until our engine needs to burn that gasoline, and it breaks those chemical bonds, and then it uses that energy that's stored in there for all of the things that it needs for the car to have kinetic energy and to move. The third type of potential energy we're talking about is gravitational potential energy. And gravitational potential energy is potential energy due to the height that an object is above the ground. And our big takeaway is the higher the height, the more gravitational potential energy an object has. So if you look at this picture, this ball right here has the most gravitational potential energy because it's higher up from the ground. And that's the type of potential energy that we will be focusing on today. So how do we find gravitational potential energy? To find gravitational potential energy, we take the mass times the gravity. Now remember, here on Earth, the gravity is always 9.8 meters per second squared, and then times the height of an object. So mass times gravity times height that the object is above the ground. And again, because this is energy, we measure in joules. So here's a sample problem. The cat has a mass of 4 kilograms and is 1.5 meters above the ground. What is the gravitational potential energy of the cat? Well, the mass of the cat is 4 kilograms, says that right here. The height above the ground is 1.5 meters. And the gravity on Earth is always 9.8 meters per second squared. So I just multiply mass times gravity times height. So 4 times 9.8 times 1.5. And because it's multiplying, remember the order doesn't matter. Type that in my calculator and I would get 58.8 joules. So let's try a problem. I'm going to write on here again. All right. So a woman with a mass of 60 kilograms climbs a set of stairs that are 3 meters high. How much gravitational potential energy does she gain as a result of the climb? So she is 60 kilograms is her mass, and the height is going to be 3 meters. So remember, all I do is I do mass times gravity times height. Okay, so we'll say gravitational potential energy equals mass times gravity times height. Her mass is 60. The gravity on Earth is always 9.8 meters per second squared. And her height is 3 meters. When I multiply all that out in my calculator, I do 60 times 9.8 times 3, and I get 1,764 joules of gravitational potential energy. All right, and then our last slide has to do with mechanical energy. And mechanical energy is the total energy of an object due to motion and position. So as the kinetic energy goes up, the potential energy goes down. And as kinetic energy goes down, potential energy goes up. But the total amount of mechanical energy always stays the same. And mechanical energy is kinetic plus potential energy. So up at the top of this guy, this person's skiing, okay, doing a ski jump. So at the top, he's not moving yet, and so his kinetic energy is 0 joules, and his potential energy is 50,000 joules. As he starts moving down the hill, now his kinetic energy is increasing, but his potential energy is decreasing because the height above ground is less. So we have the kinetic energy at 20,000 and potential at 30,000. Notice how the entire amount is still 50,000 joules. As he keeps going down here and gets to the bottom of the hill, he's moving really fast, and so his kinetic energy is at 35,000, and his potential energy is at 15,000 because now his height is a lot less. Then he jumps up here and the kinetic energy goes back down a little bit and the potential energy goes up because he's higher up above the ground. And then at the bottom, once he stops and lands, his potential energy is 0 joules and kinetic energy is 50,000 joules. So note that the total amount of energy that the skier has is always 50,000 joules. But as the potential and kinetic go up or down, the other one does the opposite. All right, so those are your notes, your big ideas. Kinetic energy is the energy of motion. Potential energy is stored energy. And the mechanical energy is the total amount of energy that an object has due to its motion and its position. And that total amount always stays the same.